Okay, this is a bonus video for this lesson on quadratic functions. You won't be tested on anything in this video, but I just wanted to show you how this notion of the parabola came about. The ancient Greeks, when they were developing algebra and geometry, when they talked about parabolas, they didn't come up with the equation first and then find out what the graph looked like. It was the other way around. They came with a geometric concept and then they found the equations, just like they did for a circle. They started with a point and a radius, and that determined the circle, and then they found the equation for that. I want to show you, well, how was a parabola defined? Well, a parabola is started with a given line and a point that was not on the line. And this actually, the parabola was defined to be all the points that are equidistant from this fixed point and the line. Okay, so in particular, like this point would be on the parabola because this distance and this distance would be the same. Okay, and they would continue like that. So this, and you can do this with any point and any line. Okay, this line is called the directrix of the parabola, and this is called the focal point. The point up here. Okay, and again, this whole idea of a focal point that's going to have some applications in physics when you're studying light and reflection and stuff like that. So I wanted to show, well, how do we get the equation of a parabola from this? Okay, so we're going to just look at this very specific situation where the directrix is a horizontal line. And we're going to say that, let's say the directrix is given by the line y equals b. Okay. And let's say the focal point has coordinates mn. Okay. And we'd like to find what is the equation for the parabola. And let's say this point xy is on this parabola. We'd like to find, and so that this distance and this distance should be the same. Okay, so if this is d1 and this is d2. Okay. All right, so what would be how do we get the equation? Well, first let's find what would this point be. The x-coordinate is going to be the same as the x-coordinate here, and then the y-coordinate, of course, would be b. So this would be x comma b. Okay. So we can use the distance formula to find d1. So we want d1 equal to d2. And then we can say, all right, this is going to be the change in the, we have x minus m squared plus y minus n squared. Okay, we take the square root of that. That's going to be d1. And d2, I think we can see that this is just going to be the square root of, now we have x minus x squared plus y minus b squared, right? Okay, and of course this is just going to be 0. And I'm going to square both sides. So we get x minus m squared plus y minus n squared equals y minus b squared. And now I'll just multiply this out. And you'll see that something very nice happens, right? The y squares cancel out. Okay. And we can get, well, there's only one x squared term. There's only one x term. And then the constant term is going to be m squared plus n squared minus b squared. And then I'm going to put all the y terms over here. We can add 2yn to both sides, so this will be 2yn minus 2yb. Okay. And this we can write this as 2yn minus b. And divide everything by 2 times n minus b. And what happens then is we get, this will be 1 over 2 quantity n minus b times x squared plus minus 2m over 2n minus b times x plus m squared plus n squared minus b squared over 2n minus b. Okay. And that's going to be equal to y. So we have, if we look at the forest through the trees here, we have y is going to be something times x squared plus something times x plus a constant. And this something times x squared can't be 0, okay, obviously. Okay, and so that is, we've just got, so this would be your A, if you will, this would be your A, this would be your B, and this would be your C. Okay, now, let's just look, what would be the directrix and the focal point for the quadratic function y equals x squared? Okay, well, in this case, that means this coefficient is 1, this coefficient 0, and this coefficient 0. Okay, so we have that 1 is equal to 1 over 2n minus b. 0 equals minus 2m over 2n minus b. And 0 equals m squared plus n squared minus b squared over 2n minus b. Okay. And then we can see, well, why are we trying to, we want to solve what's m, n, and b. So the easiest way to look at it is this second equation. This tells us m has to be 0. And if m is 0, that means that this is 0 squared is 0. And that means n squared minus b squared has to be 0. Which means n squared equals b squared. Which means either n equals b or n equals minus b. And we can't have n equaling b, right? Because we can see that this point is not on the line. So there's no way that if n equals b, then this point is as the same y coordinate, and it will be on this line. So that means that n has to be minus b. Okay. And then we can go to this back here and replace n with minus b. So we get 1 equals 1 over 2 times minus b, which means y equals 1 over 2 times minus 2b. Okay, so this means that 4b, or minus 4b equals 1, so b equals negative 1/4. Okay. And then that means that n is positive 1/4 from here. So we get that the directrix is y equals negative 1/4, and the focal point, the coordinate 0, 1/4. And if you look at the graph of y equals x squared, I guess I'll write it right here. So here's the graph of y equals x squared. Okay. The directrix is right down here at negative 1/4, and this would be 1/4 above it. And even though we don't see that, that's So that's the focal point, and that's the directrix. And that's how all parabolas are defined.